Alright, today we are going to be talking about special angles on parallel lines in 2.6. Now there's a ton of vocab, so please make sure you're pausing the video when you need to be able to catch up. Okay, this section has a lot of information and it can be overwhelming. On your conjecture sheet or in your notes, I want you to add this part in. A transversal is a line that intersects two or more coplanar lines. So I always consider these lines here to be parallel lines, always, when we're talking about a transversal. So a transversal line is any line that cuts through a set of parallel lines. Okay, so a transversal could also be going this way, that way. Okay, it could be going any way as long as it crosses a set of parallel lines. You will hear me use the term transversal quite a bit. Okay, and that just means a line that's cut through a set of parallel lines. First, before we get into our actual conjectures, you need to know what a corresponding angle is. So on your conjecture sheet, next to corresponding angles conjecture, I want you to draw this picture. Okay, a corresponding angle is an angle that lines up in the exact same spot in both sets of parallel lines. So for example, notice we have an intersection here on this top parallel line with the transversal, and then we have an intersection here as well. Notice that both angle 2 and angle 6 are in the upper right-hand corner of that intersection. So angle 2 and angle 6 would be corresponding angles. There are also 3 other corresponding angles in this picture. Okay, I'm going to show you a better example maybe for some of you. Okay, so all of these would be corresponding angles. There are always going to be 4 sets when we're dealing with 2 parallel lines. Okay, I'll go back to this picture so that you can finish drawing it down. So the corresponding angles conjecture states that if we have 2 parallel lines that's cut by a transversal, then the corresponding angles are congruent. Okay, so we have this angle and this angle would be congruent to each other, where all of the other ones are too. So I could keep going and say this angle and this angle are congruent. Okay, so if you want to add to your picture, okay, you can put congruent markings by 2 and 6. Again, if I'm going too fast, pause the video when needed. Next, we're going to be talking about alternate interior angles. Next to your alternate interior angles conjecture, I want you to draw this picture. Okay, so here we still have angle 6 from our last picture. This time we have angle 3. If you notice that both angles 3 and angle 6 are in the are inside the parallel lines. Okay, they're inside or interior. Okay, here's our parallel line. Here's our parallel line. Notice they are on the inside, not the outside. They are also alternate, which means they are on opposite sides of the transversal. Angle 3 is over on the top and angle 6 is on the bottom, or on the left and the right, whatever you want to think about it. Okay, so that makes 3 and 6 alternate interior angles. Same would go for this angle 1 and this angle 2 here. Those would also be alternate interior angles. The alternate interior angles conjecture says that if we have 2 parallel lines cut by a transversal, then the alternate interior angles are congruent to each other. Okay, so we have this one would be equal to this one. If it was 40 degrees, the other one would be 40 degrees. And then this angle and this angle would be equal. Not necessarily the same. That's why I have different congruent markings. So if you wanted to add to your picture, you could put congruent, congruent. Alternate exterior angles conjecture. So the exterior angles are the angles that are on the outside of the parallel lines. So notice 1 and 8 both fall on the outside or the exterior part of the parallel lines. And then they're also, again, on opposite sides of the transversal. 1 is over on the left, 8 is over on the right. The alternate exterior angles conjecture states that if we have two parallel lines cut by a transversal, then the alternate exterior angles are congruent. So if we know this angle is 120, this angle is 120. This angle and this angle. Okay, so there's only two sets of alternate exterior angles and two sets of alternate interior angles. Remember, corresponding had 4 sets. So if you want to go back to your picture, and if you want to put congruent markings here by angle 1 and angle 8, that would be a good idea. The parallel lines conjecture, this one combines all 3 of those conjectures we just talked about. Conjectures tend to be very repetitive at times, okay, but it's still important here. So if we have 2 parallel lines cut by a transversal, then the corresponding angles are congruent, the alternate interior angles are congruent, and the alternate exterior angles are congruent. Okay, so one final picture. Well, it's probably a lie. Okay, we have a transversal here. Okay, we have this angle, this angle, this angle, this angle. So technically, if I only know one angle out of these 8, I can find all of the other angles now. Okay, because I can use my conjecture from yesterday, the linear pairs conjecture, to help me find either the green or the red, because the green and the red, if you look at it, they form a linear pair wherever you look. Okay, and then I can use alternate exterior, alternate interior, and corresponding angles for the rest. So I only need one angle to find the other 7. Now the converse, or the opposite of the parallel lines conjecture, so kind of like the opposite of what we just talked about. Let's say we have 2 lines. Okay, I don't know if these lines are parallel, but they do have a transversal that's going through them. Now I notice that there are either corresponding angles that are congruent, alternate interior angles that are congruent, or alternate exterior angles are congruent. If I know at least one set of those, then I can say those lines are parallel. So if I know this and this, then I can say these lines are parallel. I have to have at least one corresponding or one alternate interior or one alternate exterior to show that these lines are parallel. So sometimes you might have a picture like this, and they might say, prove these lines are parallel or not. And then you would say, well, because the corresponding angles, I can now say these two lines are parallel. We're going to go through a bunch of examples. First one, find x, y, and z. Okay, if you want to try these on your own, please pause before every one, and then I will explain how I found them. For the first one, or for most of these, I'm going to ask you which conjecture you use to find them. Okay, so you can use the linear pair, vertical angles, alternate interior, alternate exterior, or corresponding conjectures. First, I'm going to find y, and I notice y and 98 are a linear pair, so they're going to add up to 180, which means y would have to be 88 degrees. Next, I see that z and y are alternate interior, so that would mean z is also 88. I could find x a couple different ways. I could use a linear pair here with z, or I can use alternate interior with 98. You should get 98 no matter how you found it. Pause the video, try it. I found h using the alternate exterior angles conjecture with 65. Okay, so 65 and h are alternate exterior angles, which would mean h is 65 as well. Pause the video to see if you can find which angle is corresponding to 65. The angle that is corresponding to 65 would be angle 2. Which angle is alternate exterior angle to 65? Pause the video. Hopefully you said angle 4. If we know angle 2 is 22 degrees, and we know that angle or line L and M are parallel, can we find the rest of the angles? Hopefully you said yes, right? Because I kind of gave it away earlier, so pause the video and try and find the rest. Okay, hopefully you got 158 and 22 for your other angles. Last but not least, if we know that angle 1 is 40 degrees, angle 7 is 140 degrees, are lines L and M parallel? Now I know looks can be deceiving. You're probably like, well, angle 1 should probably be the 140 and angle 7 should be the 40. Okay? Looks can be deceiving in geometry. Okay? Go based on the facts. Okay? Don't go based off of looks. Alright, so here, where do we start? Okay, well, I'm going to kind of work my way around. Okay, if these were parallel, that would mean that we have either corresponding alternate interior or alternate exterior. So that would mean angle 1 and angle 5 would be corresponding. So that would mean this would have to be 40 degrees. Then looking at my linear pair here with 7 and 5, 140 and 40 should add up to 180 degrees. And what do you know? They do. So lines L and M are parallel.